we've just completed the pre-algebra chapter of the algebra textbook. And so now in this video, we're going to officially start algebra. So we're going to start chapter 1. And what we're doing in this chapter is we're going to take all of the different terms and expressions that we learned about what they were and how to work with them in the pre-algebra chapter. So, just powers, x to some positive integer power, or maybe x to a negative integer power, or x to a rational exponent, so radicals. There's absolute values, rational expressions, polynomials, etc. Okay, and what we're going to be doing is we're going to be taking all of these different types of expressions and making equations or inequalities out of them, and then learning how to solve these different kinds of equations and inequalities. And so what an equation or an inequality is so it's like it's every inequation and inequality has two sides, and in the middle is either going to be an equals or one of the different types of inequalities. So less than, greater than, less than or equal to, greater than or equal to. Let's say we've got less than or equal to. Okay, now, but on both sides of the equation and the inequality is just going to be some expression. Maybe it's a big expression with all kinds of different terms being summed together, big complicated expression, or maybe it's very simple. But you're going to have one expression on one side and another expression on the other side. And for the moment, let's assume these are just expressions with one variable in them. You got an expression of just x on one side and an expression of x on the other side. Let's just keep it. Let's just stick with a simple equation with just one variable in it. And same with the inequality. We've got maybe it's this big expression with all kinds of terms being summed together, or maybe it's simple of just x on one side and another expression of just x on the other side. And the idea is, what we're wanting to do is we want to solve the equation or solve the inequality. And what that means is that we're trying to figure out what value or values of x are that. So for the equation, when you plug that value of x into the left side of the equation here, into that whole expression, and you simplify it just like we learned how to simplify in pre-algebra, you're going to get some number. And then you plug that same value of x into the other side, simplify, and you get that exact same number. That value of x would solve the equation. But we're going to think about all that potential values of x. In general, we'll be thinking about just real numbers. So what are all of the different real numbers that when you plug them into the equation, it satisfies the equation. You get one side is equal to the other side. You get the same thing on both sides when you simplify. Okay, and it's the exact same idea with the inequality, but it's not equals in this case. So you take a value of x and you plug it into the left side, and you simplify and you get a number. You take that same value of x, you plug it into the right side, you simplify and get a number. Is that number on the left less than or equal to the number on the right? Well, then if it is, then it satisfies the inequality. But then we want to know what are all the different real numbers that when you plug them in like this, it satisfies the inequality. So that's the idea of what an equation and an inequality is, and what we're trying to do when we solve it. What we're trying to figure out when we want to solve an equation or an inequality. Now, this chapter, the opening section is you can see it's linear equations and rational equations. But I've titled this video as Introduction to Equations, because really in this section, we're going to be talking about a lot of fundamental aspects of equations that aren't specific to just linear equations and rational equations. These concepts apply to all equations. So this is a really important section here that's going to talk about equations in general. But in the process, we're also going to learn about what exactly a linear equation is, as well as a rational equation. Okay, so the section starts off by giving an application example here of where something in real life you might come across in order to model it would require a linear equation. But we'll look at applications of linear and rational equations in more detail in the next section. So let's just see what exactly they're referring to when they say linear equation. So here we're going to look at the definition of a linear equation in one variable. So the first thing to think about is that you can have equations that have one variable or multiple variables. Okay, so the idea would be just like it sounds. So you've got an equation here. I'm going to put, let's see, 2x squared on one side and 3 minus x on the other side. So this, we're saying that these two expressions are equal to each other. And to solve this, we want to know what are if x can be any real number, what are all the different real numbers that when you plug them into the left side, you can take any real number on the number line. Okay, you want to find all the different real numbers that if you take that number, you plug it into the left side, you simplify and get a number. You plug that same number into the right side, you simplify and get a number. You get the same exact number. That would be one of the solutions to the equation. Okay, but you can see, though, that in this case, we've got an equation in just one variable. That variable is x. But you can have equations with any number of variables. We could do an equation in two variables. Minus 3 is equal to 3y plus 2. There's an equation in two variables, x and y. Okay, now, one thing I want to point out is that you might be thinking, well, okay, yeah, so maybe in this chapter, we're just going to learn how to solve equations in one variable, different types of equations in one variable, but like in later chapters or maybe even in more advanced algebra courses, we'll have to learn about solving equations in 2, 3, 4, 5 variables. And actually, that's not going to be the case. We're going to see at the end of this section that once we learn how to solve a linear equation in one variable, then the idea of solving a linear equation in 2 or 3 or 4 variables is just like a simple extension. It's not, there's nothing inherently different about dealing with like the same type of equation in more than one type of variable. And you'll see what I mean at the end of this section. So it's really nice. You don't have to think about, oh, it's going to be so hard to solve a linear equation in 3 or 4 variables. No, not at all. Once you know how to solve like a linear equation in one variable, then it'll be very simple to do a linear equation in any number of variables you want. Okay, so now, but this here is not a linear equation in one variable. So why not? Okay, so what is a linear equation in one variable? A linear equation in one variable is an equation that can be written in the form ax plus b is equal to 0, where a and b are real numbers, a is not equal to 0, and x is the variable. Okay, so what they're saying is that, so a and b are real numbers, and if you can take the equation and you could somehow put it into this form, maybe it starts off, it looks different, but you can somehow put it into this form where you've got just some real numbers, so a and b are constants, and you just have an x like this, then this is considered a linear equation in one variable. Okay, so how can we make what are they talking about here? How can we make some sense of this? Well, okay, I'm going to give you a description here of a linear equation that I think is going to be really helpful for you to, it'll be an easy transition when you're trying to categorize an equation that has not just one variable, but multiple variables. So, all right, we've talked about in the pre-algebra chapter what a polynomial is. And we were given the official definition of a polynomial, but a more unofficial definition that I gave you was that if you have any expression, okay, it can have as many terms, the number of terms doesn't matter, okay, and the number of variables doesn't matter. These terms could be multiplying all kinds of different variables, whatever, okay? If all of the variable terms, so like you have 3x squared yz minus 2xg plus etc., whatever. Okay, if every single, you can go to every single variable and it's raised to a whole number power and nothing different. So a whole number would be 0, 1, 2, 3, 4. So like you could have something to the 0 would just be 1. Okay, there's no variable that you cannot find any variable in the entire expression that is raised to something other than a whole number, then you look at that as that's a polynomial. Okay, that's a polynomial. If you find just one that's raised to something, now this expression here is not a polynomial. This term is a polynomial term, but this expression here is not a polynomial anymore. Okay, and so whenever you look at an equation, the first thing you're going to want to look for is look at with an equation or an inequality, you'll have, like we talked about, you'll have one expression on the left, one expression on the right. Maybe the one on the left is very complicated, the one on the left is very simple, whatever. Okay, if you go to every single term on both the left and the right, and you see that every single variable is raised to a strictly whole number power, okay, then you're dealing with some sort of like you would call it a polynomial equation, okay? That's the first thing you want to look for when you look at an equation. Is this equation consist of strictly polynomial terms, okay? Then you could call it a polynomial equation. And it's important to identify if you have a polynomial equation, because a linear equation is just one type of polynomial equation. All a linear equation is going to be, it's going to be the case where, okay, it's a polynomial equation. However, in addition to that, a linear equation is going to be a subset of polynomial equations. In addition to that, every single variable is raised to strictly a whole number power. With a linear equation, that power is going to be either 1 or 0. So if you have like a variable to the 0 power, it won't even be showing a variable. It will just be 1. But like technically, like if you had a constant here, well, this is times x to the 0, right? So yeah, but if you've identified you have an equation or an inequality that's a polynomial equation or inequality, and you further identify that every single variable is strictly raised to the power 1 or 0, but again, you wouldn't even see the 0 power, then it is a linear equation. And then is it a linear equation in 1, 2, or 3 variables? Just count the number of different variables. This would be if I took off the 2 here, this would be a linear equation in 1, 2, 4 variables. Or no, no, this is a linear expression. So if I did 4x, y, okay, this is a linear equation now in 4 variables. That's the idea. Okay, so now you can see why is this a linear equation in one variable? Because if you look on the right, well, that's just 0. It's as simple of an expression as you get. Then you look on the left, but there's no variable terms raised to something other than 1 or 0. You look on the right, and you've got this one variable term. These are constants. This one variable term raised to the first power. So this is a polynomial equation, but it's a specific type of polynomial equation because we just have one variable and it's raised to the first power. And so it's not just polynomial, it's a linear equation in one variable. Now, no, it's not. And I want to be clear. It doesn't mean that if you came over here and you had is equal to cx plus 5, oh, well, now there's 2 variables. No. It's the same variable, and they're both raised to the first power. So this is a linear equation in one variable. Okay, now, it does mention that a and b, these coefficients here, are real numbers. And without going too deep into this, you can think about just talking about complex numbers. Since we've talked about how like an expression with I, that's also a constant, then you can think about it would probably make sense that you could allow a and b to be real or complex numbers, and you would still have a linear equation in one variable. Now, I'm not making any official statements on this yet, but because I don't want to confuse you too much, but yeah, it would make sense since I is just a constant number that you could actually say, well, a and b could be real or complex numbers, whatever, as long as all you've got is this single type of variable to the first power in the entire equation, then you still have a linear equation in one variable. Okay, so now a linear equation in one variable is also called a first degree equation because the degree of the variable term must be exactly 1. So what they're talking about here is that, as I mentioned, the linear equation, you can look at it as a subcategory or a subset of polynomial equations, right? Well, we know with polynomials, you can assign degrees to them based on the highest order term. Well, in that case, then a linear equation would be a first degree polynomial equation, or just a first degree equation. That's what they're talking about here. Okay, so here's some examples of equations that are linear equations in one variable and some that aren't. So 5x plus 35 is equal to 0. We've got x to the first, and that's it. Linear equation in one variable. Here, 5x squared, no. No, this is a polynomial equation. It's just got these variables strictly with these whole number exponents, but it's not linear though. Okay, here, this is kind of confusing, but if you look closely, this 1/4 is just a coefficient in front of the x. So, yeah, that's a linear equation. Now, if you look at this, the one next to it, what about this? Well, no, because this is 4x to the minus 1. Minus 1 is not a whole number. So remember, you have to go to every single term in the entire equation, every single term. If you find just one variable that's raised to something that's not a whole number, then it's not going to be a polynomial equation, which means it's not going to be a linear equation. Okay, let's see. Here, yeah, that's linear, no problem. Here, what about this? What about 3x plus 4y is equal to 7? Well, you go to every single term, and you're looking for variables that are, and looking at what powers they're raised to. Well, here, all of the variables are raised to the first power. Okay, great. That's like a polynomial. That is linear. However, it's not a linear equation in one variable is what they're saying. It's a linear equation in two variables. So it is linear, but it's not in one variable. Okay, and now what about these two? Well, here they're just trying to confuse you with these decimals, but those are just coefficients. You could have any real number that's multiplying the variable. So 0.7 times x to the first minus 0.8 is equal to 0.1. That's okay. Linear equation in one variable, no problem. What about this? Yeah, what about this? Is this a linear equation in one variable? You might say, well, yeah, it is. I mean, look, x to the first, 0.7, 0.8, 0.1 are just numbers. Well, they're trying to trick you here because, no, there's not an equation. Where's an equation has to have two sides to it. This is just an expression. Okay. So, now, a solution to an equation is a value of the variable that makes the equation a true statement. So, yeah, I talked about at the beginning of the video the idea of a solution to an equation or an inequality. You're just trying to find any number on the real number line, or you can think about this could apply to any number in the complex plane as well, but let's stick with the real number line. You're trying to find any number on the real number line that when you pick it out, you plug it into both sides of the equation or the inequality, and you simplify and get numbers, it satisfies the equation or the inequality. That would be it, and that's what they're saying is then you have a solution. That's a solution. Okay? Now, you could potentially have multiple solutions, right? So the set of all solutions to an equation or an inequality is called the solution set of the equation. Equivalent solutions have the same solution set. So what they're talking about here is that if you could have two separate equations or inequalities that if they have the same solution set, then those are equivalent equations, right? So if you have these two separate equations and they have the exact same solution set, then you call those equivalent equations, okay? So to solve a linear equation in one variable, we form simpler equivalent equations until we obtain an equation whose solution is obvious. The properties used to produce equivalent equations include the addition and multiplication properties of equality. So yeah, what we're about to talk about here is we're learning how to solve a linear equation in one variable. That's the simplest type of equation. But this process here, we're going to do this to solve any type of equation or inequality. Now, I'm going to stop saying inequality as we go forward because we'll come to inequalities later. So, yeah, so this process, this idea for how we're going to solve this linear equation in one variable, this is going to be the same process we're going to apply to solve any kind of equation, with radicals, whatever. Okay, what they're saying is what we do is we form simpler equivalent equations. So equations that they're equivalent because they have the same exact solution set until we obtain an equation whose solution is obvious. So we're going to start with a linear equation in one variable like this, okay? Now, if we can form, what we're trying to find is the solution set to this. That's what we want, right? We want the solution set to this. All the values of x that when you plug them in to this equation, it satisfies the equation. That's what we're trying to figure out. So if we can find or produce some equivalent equations that we know have the same solution set, but they're simpler, well then great. Then that if we can make it simpler and simpler and simpler and then get some like really equation that has an obvious solution set, like x is equal to just some number, right? Well, if we know it's equivalent to this, then we have the solutions to this. You see, that's the idea. So now, how do we produce these simpler equivalent equations? It says the properties used to produce equivalent equations include the addition and multiplication properties of equality. Okay, so let's come here and see what they're talking about. So let A, B, and C be real valued expressions. Okay, but again, just to point out, this stuff is going to extend pretty seamlessly to complex valued expressions as well, but we're going to just focus on real valued expressions. So just notice, though, that what they're saying here when they say a real valued expression, remember what an expression is. It's not just a number. An expression is any jumble of variable terms. You could be summing 5 different variable terms with all kind of stuff going on. That's an expression. If those variables as a unit, 1/2 x squared y minus 3x plus 2zx. Well, as a unit, this is just like a placeholder as a group for some number, some real number. You pick an x, y, and a z, and you plug that in and you simplify this, you're going to get a real number. So what you could do is you could just say, okay, I'm going to say this is equal to a. Right? That's what they're saying. A, B, and C, like this could be a right here. This could be a. So that's why I'm trying to point out that we're not just talking about linear equations here or linear equations in one variable. These properties of equality are going to apply to all of the equations we're going to solve. Okay? So what is the addition property of equality? So the addition property of equality says that, so if you have an equation that A is equal to B, you have this equation, then this equation is equivalent to if you added the same expression or number, whatever, to both sides. So these are equivalent, meaning that their solution sets are the same, right? Remember what an equivalent equation means. It means that they have the same solution set, which is important because that's what we're trying to figure out, the solution set to this. So if by doing this, adding something to both sides, we can make this equation simpler, and we keep doing that without going away from having an equivalent equation, then at some point we're going to get down to some like really like simple looking equation where we can just read off the solutions. And we know that since that equation in the end is equivalent to the original equation, then we know we're reading off the solutions to the original equation. Okay? Now, so that's the addition property of equality, but you might say, well, what about the subtraction property of equality? Well, no, C is whatever you want it to be. C could be -3. You know, this implies you could subtract the same thing from both sides as well, and you don't change the equation. Okay, now this applies to, there's the multiplication property of equality as well. So this equation, A is equal to B, is equivalent to if you multiply the same number or expression on both sides. You haven't changed the equation. Okay, but it notes that C can't be equal to 0, because then what happens? Then you get 0 is equal to 0, and you've that's not going to work. Now you've eliminated all the information. Okay, but notice that you can apply this for the case of division, in the sense that you could say that if you want to divide C by both sides, well, and then you would say, okay, 1 over C times A is equal to B times 1 over C. And in the same kind of way, C can't be equal to 0 because you can't divide by 0. But anything else is fine. You haven't changed the equation. Okay? So now, these are the properties of equality that we use to solve equations, any kind of equation. But now, how can we use what we just learned here to solve a linear equation in one variable? Okay, well, what we're going to do is we're going to isolate the variable by following these guidelines. So it says, step 1, you simplify both sides of the equation. So you use the distributive property to clear parentheses, combine like terms. Consider you clearing fractions by, you can multiply both sides of the equation by the least common denominator of all the fractions. Okay, then once you've simplified both sides, then you use the addition property of equality to collect the variable terms on one side of the equation and the constant terms on the other side. Okay, then you use the multiplication property of equality to make the coefficient of the variable term equal to 1. So then what you're left with is, if you read through this again, what you're left with is the variable on one side with a coefficient of 1 is equal to some constant. Well, what's the solution to that equation? Well, we can see what it is. We just read it. And since we haven't changed the equivalence of the equation, that's going to be the solution to the original equation. Okay, now then, step 4 is, it says you check the potential solution in the original equation. So yeah, you get a number like x is equal to 3. Okay, well for a linear equation, there's only going to be one solution. So that's the solution. So you go back to the original equation and you plug it in and see, okay, is this a solution, right? When you plug it in, does the left side, when you simplify it, equal to the right side when you simplify it? To verify that it is a solution. If it is, then you just write the solution set or box it in. Say, there it is. That's the solution. Okay, so let's look at this example here. So minus 3 times w minus 4 plus 5 is equal to 10 minus w plus 1. Okay, so we look at this equation here, and it's good practice to look at it and say, okay, what type of equation is this? Well, okay, when you look at both expressions, any equation is going to have an expression on one side and an expression on the other side. And you first notice, okay, look at all of the variables. What power are they raised to? Well, these variables are all raised to whole number powers, so we know this is a polynomial equation, but it's actually a subset of polynomial equations, because all of these variables are raised to the power 1. So it's actually a linear equation, and we've only got one type of variable in this entire equation, so it's a linear equation in one variable. So it's really good practice to identify the type of equation you're working with. So, okay. So with that, then we can go through these steps here, but these steps, what they're really saying is that the idea is, this is what we're trying to do when we solve any equation. We're trying to use the properties of equality, so adding something to both sides, subtracting something to both sides, multiplying, dividing something to both sides, and at the end, we want to isolate the variable on one side and constants on the other side, and then make it to where the variable on the one side has a coefficient of 1, to where we're just reading off the variable is equal to some constant or constants. That's the whole goal. We're trying to use the properties of equality to do this. And so what they're saying here is that in these suggestions for solving an equation in one variable, but this is really going to apply to any type of equation in general. They're saying, okay, well, why don't you just start by simplify the left and the right side expressions as much as you can. So clear all the parentheses, all the exponents, etc., as much as you can. So, okay, let's come to this side. Let's distribute this. So minus 3w minus 3 times minus 4 is 12. Okay, plus 5. We've got rid of that parentheses. Okay, now here we can distribute this minus, and so we get 10 minus w minus 1. Okay, but now we can continue to simplify because we've got 12 plus 5. Okay, now here we've got 10 minus 1 is 9. Okay, so yeah, this is going to be much easier to work with than what we started with. And we haven't changed the equation, obviously. We just simplified with the expressions on either side. So you can see how these steps for solving a linear equation, in general, you're gonna this is how you'd solve any equation. Just start to simplify the expressions on both sides as much as you can. Get it simplified as much as you can and then go from there. So now what do we want to do? Well, now we want to isolate the variable terms on one side and the constant terms on the other side. Because at the end of the day, we're trying to just get it to where we've got the variable by itself with a coefficient of 1 on one side and just constants on the other side. So, typically I like to do it, since we read left to right, I like to put the variables on the left side. So, okay, how can we isolate? What do they mean by isolating the variables on one side? Like, how do you think we could do that here? Well, okay, if we're trying to have all the variables on the left side, well, then we want to get rid of the variables on the right side. So we can do that by, if we could add a w over here, we could do that, because minus w plus w is equal to 0. But we can't just do this and that's it. Now we've changed the equation, right? We have to use these properties of equality of equations. So we need to add w to both sides. Now we haven't changed the equation. We have the solution set to this equation is exactly the same, since we added w to both sides. And the solution set is this, the solution set to this. That's what we're trying to figure out. You see, since we added w to both sides, we haven't changed the solution set. So this is great, because now we've got, so w minus 3w is minus 2w, okay, plus 17. But now minus w plus w is 0. So now we've gotten rid of the w on one side of the equation, okay? But what we're trying to do, though, is we want to isolate the variable terms on one side and the constant terms on the other side. So let's get rid of this constant term here and have all constants over here. We can do that by subtracting 17 from both sides. So we're left with minus 2w is equal to 9 minus 17 is minus 8. Okay, so now we're getting somewhere. This is significantly simpler than what we started with. But we haven't changed the equation. The solution set is still the same. In other words, whatever w we would plug in here to satisfy this equation, so there's some number on the real number line, number or maybe numbers, but there's only, with linear equations in one variable, there's going to be just one number, that when you plug that real number in and you multiply it by minus 2, you're going to get minus 8. There's some number on the real number line that when you multiply it by negative 2, you're going to get minus 8. And we know that exact same number, when you plug it in here and you simplify the left side and simplify the right side, you're going to get the same value. We know that because we haven't changed the equation. We've just applied these properties of equality here for equations. So, okay, but we're not done, though, yet, because we can, let's get this w with a coefficient of 1 in front of it. So to do that, we want to multiply both sides by minus 1 over 2. Or you can think about divide both sides by minus 2. Okay, so we're left with w is equal to minus 8 divided by minus 2 is 4. Okay, so now we've got to the point, it doesn't get any simpler of an equation than this. What is the solution to this equation? Right? Solve this equation. What number on the number line, when you plug it in for w, do you get 4? Well, okay, yeah, it's 4. Right? That's the whole idea. So the solution to this equation is 4, but we know that these two equations are equivalent, so the solution to this equation must be 4. And you could plug it in and check just to make sure you didn't make any errors. Now, when it comes to equations like linear equations in one variable, as long as you don't make any math errors, you're going to have the solution's going to be correct. Now, it's always good practice to check, but it's going to be correct. But we're going to see equations later that just because you don't make any math errors, it still could be the case that some of the solutions you found aren't going to check out in the original equation. This isn't very common, but that is going to be the case for some circumstances, and so we'll talk about that. Okay, let's work another example. Let's solve this equation here. So we've got m minus 2 over 5 minus m minus 4 over 2 is equal to m plus 5 over 15 plus 2. Okay, so it's always good practice to when you first look at an equation to identify what type of equation it is. So we look at this and we come to each term, to each variable, and we look at what power is that variable raised to. And in this case, all of these variables are raised to the power 1. So they're all raised to whole number powers. So we can look at this as a polynomial equation, but even more specifically, it's a subset of polynomial equations because every variable is raised to the power 1. And I guess technically there's some that are raised to the power 0 as well, but you get the idea. Okay, so this is a linear equation, but also we see that there's only one variable in this equation, the variable m. So more specifically, this is a linear equation in one variable. Now, just to point out, the fact that we've identified that it's a linear equation in one variable, does that mean that, going forward, every time you identify what type of equation you have, depending on the type of equation, you're going to have some drastically different method of solving it? No, not at all. I mean, there's going to be subtle nuances and some differences here and there, but it's all going to come down to just using these properties of equality to get simpler and simpler equivalent equations until you can isolate the variable on one side with a coefficient of 1 and like constant or constants on the other side. It's all going to be, it's that same idea for any type of equation. And the process here that was laid out for solving these linear equations, this isn't unique to linear equations. It's the same idea for any type of equation. So like we start with we want to simplify both sides of the equation as much as possible. Well, okay, we would do that with any type of equation. Okay, well, one of the ways we can simplify is by clearing fractions. It says, so let's see. Yeah, consider clearing fractions. Okay, well, yeah, let's do that here. Let's start by, let's clear these fractions. And we do that by multiplying both sides of the equation by the least common denominator of all of the fractions in the entire equation. So 5, 2, and 15, the least common denominator would be 30. So now when you're multiplying something by both sides of an equation, you could do it like this. That's fine, but another way you can do it is you can say like you're multiplying the entire equation by 30. And that means the same thing. And do it like that. That means it's the same thing. Same meaning. So okay, 30 divided by 5 is 6. So we'll get okay, yeah, I don't want to, let me actually do it this way just to make sure you don't get confused. So yeah, we're multiplying this entire expression by 30. And we're multiplying this entire expression by 30. Okay, so how do we multiply 30 by this entire expression? Well, we distribute to each term, right? So what is 30 times m minus 2 divided by 5? Well, okay, 30 divided by 5 is 6. So we're left with 6 times m minus 2. Okay, multiplying 30 by this term here, we're going to get 15 times m minus 4. Okay, is equal to, now let's distribute the 30 here. So 30 divided by 15 is 2. So we're going to have 2 times m plus 5, and then 30 times 2 is 60. Now we've cleared the fractions. So next step is let's just simplify each of the expressions on each side as much as possible. Let's clear these parentheses and combine like terms. So, okay, distributing this 6, you have 6m minus 12. Okay, distributing that minus 15, you've got minus 15m, and then plus 60. Okay, distributing that 2m plus 10, and then plus 60. Okay, now let's just continue to simplify. Let's combine like terms. So let's see, minus 12 plus 60 is going to be positive 48. 6m minus 15m is going to be minus 9m. Okay, then we're going to have 2m plus 70. So, I mean, this is great. We haven't changed this equation, this original equation at all. This is equivalent to the original equation. Equivalent meaning it has the same solution set. But we're much better equipped at this point to figure out, well, what values of m on the real number line can you plug in here? And, you know, you take 48 and subtract that from, or subtract 9 times that value from 48, and then get a number, and then take 2 times that value and add it to 70 and get a number, and those numbers are equal. What values of m is that going to be the case? We're much better equipped to figure that out here than having to do it here, because whatever those values of m are that satisfy this, we know are also going to satisfy this. Okay, but we don't need to stop here. We can just keep going. So let's bring the variable terms to one side and the constant terms to the other side. So let's subtract 2m from both sides, which is the same idea as saying minus 2m plus. Okay, so the 2m minus 2m is 0, and we're left with, so 48. And just to, you might be confused by that. Let me, like, okay, I added 2m or I added negative 2m to the left side, right? Well, I could also add negative 2m to this side. You see? So that's kind of what, I don't want to confuse you by putting minus 2m over here like this. Instead of subtracting minus 2m, it's the same idea. So, okay. 48, and then minus 2m minus 9m is minus 7m. Okay, then 2m minus 2m is 0, and we're left with 70. Or no. 2m minus 9m is 11m. Minus 2m minus 9m is 11m. Okay, now let's subtract 48 from both sides. And we're left with minus 11m is equal to 22. Now we can multiply both sides by minus 1 over 11, or divide both sides by minus 11, and we're left with m is equal to minus 2. Okay, so this is great because we use the properties of equality for equations and reduce this original equation down all the way to this point. We have this is still an equation, but the solutions to this equation are obvious. What values of m on the number line satisfy this equation? So when you plug them into for m, do you get the left side is equal to the right side? Well, there's only one value. It's obvious. It's minus 2. But this equation is equivalent to this equation, which means the solutions to this equation are the same as the solutions to this equation. That means the solution to this equation is minus 2. We know that as long as we didn't make any arithmetic errors, math errors. If you plug in minus 2 for m, you're going to get a number over here. And then when you simplify, and then you plug in minus 2 over here, you simplify, you're going to get that same number. Okay, so this is really interesting stuff, and we're going to continue in the next video to talk about the fundamentals of equations and solving equations. Next, we're gonna look at, so any equation is going to be one of 3 types. It's either going to be conditional, or it's going to be an identity, or it's going to be a contradiction. Any equation, not just linear equations. We're really in this opening section. We're We're being introduced to just equations in general. So I'll see you in the next video.